medication to draw up out of a vial to give a patient an IV bolus. This method will not work and can't be used with our fluid over time problems and our medication infusion problems. We still need to use the respective formulas for those because we have to account for the drop set that we're using, and in fluid over time, we have to account for the amount of time to give the medication, and in infusions, we have to account for the specific drug concentration. The ratio method, and basically what it involves is we take our medication math problem and we separate it into two ratios. We separate it into a known ratio, which is essentially the amount of medication that we have in the vial in front of us. So how many milligrams or micrograms are in the vial and how many milliliters is that medication mixed in with. And our unknown ratio is our desired dose divided by X, where X represents the amount of milliliters that we need to give or what we need to solve for. So with this method, we're solving for X. Let's look at an example problem. Say I needed to give a patient epinephrine 1 to 10, and I need to give them 0.4 milligrams, and I have the vial of epinephrine that's 1 milligram in 10 milliliters. And I need to know how many mLs to give my patient. So I can use the ratio method to solve this problem. The first step is going to make our multiplication a little bit easier, and that's going to be to reduce my medication concentration down to the amount of medication per 1 milliliter. So because I have 10 as my denominator, I can go ahead and move the decimal place one place to the left on this side, do the same thing on this side, and I get 0.1 milligrams per milliliter. So now I've got that done. I'm ready to set up my ratio. I'm going to start with my known ratio, which is the medication that I have in the vial, which I know is now 0.1 milligrams in 1 milliliter. So that's my known ratio. So that's going to look like this, 0.1 milligrams in 1 milliliter. I'm going to write an equal sign, just like I did up here at the top. And then I need to figure out what my unknown ratio is going to be. Well, I know my desired dose is 0.4 milligrams. So that's going to go at the top. 0.4 milligrams is going to go at the top. And that's going to get divided by X, which is the amount of milliliters that I need to give. So now I just need to solve for X. So when we use this ratio method, we're going to basically cross multiply. So I'm going to take 0.4 and multiply that by 1. And that's going to give me 0.4. Okay, equal sign comes down. Then I'm going to cross multiply the other side, 0.1 times X, and that's going to give me 0.1X. Okay, so now that I have this in a different look, I need to solve for X. So I need to get X by itself. The way I'm going to do that is I'm going to divide this side by 0.1. That will cancel itself out. And I'm going to divide this side by 0.1. So now I can rewrite this, and it's going to say X, or it's going to say X is equal to 0.4 divided by 0.1. So when I write this like this, it's going to look like 0.1 divided by 0.4. Now, when you're dividing by decimals, I cannot leave a decimal right here because we're not able to divide that way. It's like dividing a fraction by a fraction. You're not able to do it. So I need to convert 0.1 to a whole number first. So I'm going to take this and move the decimal place one place to make it a 1. And because I did it here, I need to also do it on the inside. And I'm going to take the decimal here and move it one place here. And that's going to become 4. So now I'm doing 1 divided by 4, which we know is 4. So X equals 4, which means I'm giving my patient 4 milliliters. A problem like this, you can also just use basic reasoning to find the answer and avoid having to do any of this math. If I know that there's 0.1 milligrams in 1 milliliter, then if I need to give 0.4 milligrams, I'm going to draw up 4 milliliters. Let's look at another one. Say we need to give a patient 15 milligrams of a drug. And inside of our vial, I have 40 milligrams in 20 milliliters. Well, I'm going to start by reducing this down. I know that 40 divided by 20, I'm going to end up with 2. So that's 2 milligrams per milliliter. So now that I know what my drug concentration is reduced down, my known ratio is going to be 2 milligrams per 1 milliliter. And that's going to equal my desired dose here, which is 15 milligrams, and X that I'm trying to solve for. So now that we know what the underlying process is of how I get to X and how I isolate X by itself, I can easily in my head go ahead and say, okay, well, I'm going to do 15 times 1, which is 15, and then that needs to get divided by 2 is going to equal X. So 2 into 15 is going to go 7 times, and that's going to give me 14, 0, so 7.5. So with this example, X is equal to 7.5, and that is how many milliliters I will need to draw up to give to my patient. One more example. I want to give 25 micrograms, and I have a vial of medicine that is 100 micrograms in 2 milliliters. Okay, I'm going to reduce this concentration down. I know that's going to give me 50 micrograms in 1 milliliter. And this is a pretty easy problem, right? I know that I'm going to give 0.5 mLs. But I'm still going to show you this ratio method so that you can see kind of the underlying process when you have a more difficult example. My known ratio in this case is 50 micrograms over 1 milliliter. And that equals my desired dose, which in this case is 25 micrograms over X that I need to solve for. Now, this is a good time to go ahead and mention that with this ratio method, the only way that it's going to work is if my units of measurement match, so micrograms and micrograms. If my medication was packaged in, say, milligrams, and I left it in milligrams, this ratio method will not work and you'll get the wrong answer. So you need to make sure they match across the top. So now that I have this set up, I can go ahead and do my cross multiplication. 25 times 1 is 25. 50 times X is 50X. Divide by 50, cancels out, that isolates X. What you do to one side, you must do to the other side. So 25 divided by 50 is going to equal X. So now I know that X is equal to 25 divided by 50. So to do long multiplication, just to show you how that works, I know we can do that in our head and get the answer, but I'm going to do it anyway. So 50, how many times does that go into 25? Well, there's a decimal point here. So we're going to bring that decimal place up to there. 50 doesn't go into 25, so I'm going to add a 0 and say that's 250. 50 goes into 250 5 times. 50 times 5 is 250. So now I'm at 0. So my answer is X is equal to 0.5 milliliters. One good thing about the ratio method here is we can check our answer, right? I can come back over here to my original and I can plug in 0.5 and it should equal. So if I were to do 50 times 0.5, that's going to equal 25, which is the same as 25 times 1. I hope that helps. Please use the method that works best for you. The ratio method and the single dose formula method are the two most common methods. There's a third one called dimensional analysis, but that one's pretty hard to wrap your head around. So I recommend either the ratio or the single dose formula method. Please make sure that you're memorizing your fluid over time and your medication infusion formulas so that you can get those questions correct, because those types of questions are more complex.